Yeah, so good evening everyone. Good evening. Please check audio video okay or not. Verify audio video okay or not, so that we can start. Sorry for delay first of all. Yeah, now I am starting. Yeah, let me share the screen. Yeah, perfect. Yeah, sorry for delay. So we are starting now. We are starting now. Everything is ready. Careful, careful everyone. This is crash batch for GATE CSE 2027. So careful, careful everyone. So let me store first uh, TOC crash batch save. Yeah, everything is fine. So let me yeah, everything is fine now. So I'm starting crash batch GATE CSE 2027. So starting subject is TOC. Starting subject is TOC, Theory of Computation. Theory of Computation. Yeah, so first chapter is Finite Automata, Regular Expressions, Regular Languages. That is the first chapter. Second chapter, PDA, Context-Free Languages, Deterministic Context-Free Languages. 3, Turing Machine, Turing Machine. Next one is Recursive Languages, Recursive Enumerable Languages. Fourth one, Undecidability. Right? Undecidability. So this is the first chapter. Sorry, this is the first subject of crash course Theory of Computation. So these are the 4 chapters. So remember everyone, actual course is 70 hours. Actual course is 70 hours. It is a crash course. It will be done 20 to 30 hours. It will be done 20 to 30 hours. Please be careful. Actual course is 70 hours, but here it will be done crash course 20 to 30 hours. It will be really beneficial for 2027 students. If you are preparing for 2027, I suggest everyone, please follow this because you don't have enough time. You don't have enough time, please comfortably everyone can follow. Sir, I am not done TOC, sir. Comfortably you can follow this. Crash batch GATE CSE 2027. 20 to 30 hours. Approximately I can say 10 days I will finish it off. Within 10 days it will be over. Theory of Computation, Finite Automata, Regular Languages, Regular Expression, PDA, Context-Free Languages, DCFL, Turing Machine, Recursive Language, Recursive Enumerable Language, and Decidability. Okay, fine. Fine. Now let's come to the right today's class in my opinion just started now. Today's class just started now. Can you say what is the today's date? Please let me know what is the today's date. In my opinion, today's class is just started now. Make it fast. What will be the today's date? In my opinion, today's class is just started now. 24th, so I'm writing now. 24th, 8, 26. I hope this is the date. 24/8/26. 24/8/26. This is the date, right? I'm starting now. So remember. So just I'm talking about here in automata, in TOC is also called as automata theory of computation, which is also called as automata because we will normally discuss about automatas. So in automata, we'll discuss about only formal languages. The first thing which required is formal languages. Right out? This is the first one. Formal languages. Right? First one is formal languages. This is the first one. In this subject, we will discuss about only formal languages. So what is a formal language? All the things I will discuss, right? Let's go ahead. Formal language. Remember, formal language. Just give me 1 minute. Fine. Just 1 minute. Right, perfect. Yeah, we'll talk about formal language. First one is formal. What is formal language? Please take care, everyone. Formal language. It is collection of string. When you say language, no, collection of strings only. When you say language, it is a collection of strings only, right? It is also collection of strings only. It is also, when you say language, collection of strings, na, it is also collection of strings only. Collection of strings only. But here meaning of the string is not important. Meaning of the string not important. Only format of the string is important. So please be careful. This is the meaning of in automata, in TOC, this is the major one. Right? TOC, what is the first thing required? In TOC, what is the first thing required? TOC, the first thing which required is formal language. What is formal language? When you say language, collection of string, it is also collection of strings only, no doubt. But here, meaning of the string is not important. But, right? But format of the string is important. Right? Only format of the string is important. Some people are asking, what may be this? Sir, what it means? Ready, sir, what it means? Exactly what you want to say here. Right? So I will give some examples. See the examples. See the examples here. Suppose assume it is a language. Language L1 is equal to, assume a power n, where n is greater than or equal to 1. So, right, if you see the language L1, it is in general notation is that L1 is equal to a power n, where n is greater than or equal to 1. That's okay. But if you see the L1, n value 1, single a, n value 2, double a, n value 3, triple a, n value 4, 4 a's, and so on. So, but if you observe here, right, what is the meaning of triple a? Triple a, there is no meaning. Meanings not there. Triple A, there is no meaning. But a triple A having format, what is the meaning? 1A followed by one more A followed by one more A. Triple A continuously. 4 A's continuously. See, this is the format. What is the format here? N A's. What is the language? N A's, where n tends to 1 to infinite. And one more, it is infinite language, right? Remember, because there is no boundary, right? Infinite language, it is infinite language because there is no ending boundary. It's infinite language. And one more, infinite formal language. Here meanings are not important. It is an infinite formal language. Please be careful. It is an infinite formal language. But if you observe clearly here, what is the format? 3A's. That is a format. Format is 3A's. But what is the problem here? No meaning. Meaning we are not interested. No meaning. But here format is 3A's. So in TOC, we will discuss about only formal languages. Are you okay with this? The first thing, if anyone said TOC, what is the first thing required? Formal language. What is the formal language? Collection of strings. The collection of strings means that is a language, but here meaning is not important. Only format important. What is the format? N is where n tends to right 1 to infinite. Why infinite? That is the reason it is called right. This is the infinite formal language. It's a formal language, but infinite, no limits. What is the last string? N is right. N can be anything. N can be anything. I think let me give one more example. Let me give one more example. L2 is equal to, listen, L2 is equal to A power m, P power n, where m comma n greater than or equal to 1. So if you observe clearly, L2 strings properly, m comma n greater than or equal to 1. You can take 1 also, A, B. Next one, m you can take 2, n you can take 1, double A 2, 1B, and triple A 1B, and so many A's followed by single B in the similar way, single A followed by double B, single A followed by triple B, right? So many A's followed by so many B's, so many B's. So remember here meanings not important. Only format is important. What is the format? M number of A's followed by n number of B's, where m and n minimum is 1, maximum no boundary. So infinite language, it is infinite formal language. It is infinite formal language. It is infinite formal language. It is a formal language, no doubt. But what is the ending string? We don't know. We don't know what is the ending string. It can be anything. There is no boundary. So it's an infinite formal language. It's one more formal language. Remember, in the TOC, we will discuss from first class to last class about formal languages only. This subject is completely based on formal languages. This subject is completely based on formal languages. Please be careful. So some people are asking, what about this? Sir, is it also formal language? Let me write. See this one. L3 is equal to L3 is equal to, remember L3 is equal to this one means L3 language, right? L3 language don't have anything, which is nothing but pi. Both are same. So it's called L2 is empty language. L2 is formal language only, but empty language because nothing is there inside, no string. But in the L2, how many strings are there? Infinite strings. So infinite formal language. L1 contain how many strings? Infinite strings. So infinite formal language. But if you see the L3, no string is there. L3 don't have string. So right, sorry, L3 don't have string. So L3 is empty language. It's a formal language. It's a formal language, no doubt. So L3 is formal language. L3 is formal language. That is okay. And one more. L3 is formal language. L3 is finite formal language. Finite. L3 is finite formal language. Finite formal language. So be careful. Right? Fine. Can we move to next? Next one. Right? L3 is empty language. L3 is empty language. L3 is empty language. Let me know if anyone having small doubt also. Let me know if anyone having small doubt also. Sir, I have this doubt. Remember, today's class is just started from here. Today's class is just started from here. What is formal language? Simply collection of strings. But difference, meaning is not important, format is important. What it means, right? So I given one example, L1. Here, n number of A's, 5 A's. What is the meaning? No meaning. But what is the format? 5 A's. So and next one, how many strings are there? Infinite. So it is infinite formal language. So only one formal language or meaning L2. A power m, B power n, where m comma n greater than or equal to 1. So I think m comma n, you can keep on change. So if you observe clearly, m is followed by n b's. M is followed by n b's. M can be minimum 1, n can be minimum 1, right? So I think AB, double AB, triple AB, so many A's followed by B, single A followed by so many B's, and so on. So many A's followed by so many B's, right? Yeah, it is also infinite formal language. So L3, some people are asking, sir, formal languages are every time infinite? Need not be. Right? Formal language can be, right, can be finite also. See, L3 don't have anything. So L3 is empty language. Because of empty, no one is there. I think 0 people are there inside. So L3 is a finite formal language. L3 is a finite formal language. Are you okay till now? Ready? Right? So some people are asking, sir, I have doubt. Let me know what doubt you have. I will clarify. If you have any doubt, let me know. I will clarify. Can we move further? Can we move further? Can we move further? Little doubt also there in the comment section, you can comment. In the comment section, you can comment. Yeah, let me say one important thing. Let me say one important thing here before going further. Right? So remember 21st August, I think on Friday, this batch is started. Crash course is started. This batch is started on Friday. Right? TOC subject is going on crash course. It's a live batch. It's a live batch, right? So 21st August, this batch is started. It's a live batch, right? As of now, whatever is going on, same. First subject is TOC. 7:30 is time. Next one, new RIC batch is starting. New RIC batch is starting 28th of August. 28th of August, new RIC batch is starting. So remember, this contain 3,500 quality questions from all the subjects. 3,500 quality questions. Every subject approximately 300 questions. 3,500 quality questions with video solution. So expected to be last year 40 questions came from RIC course and a test series. RIC and test series 40 questions came almost directly. Almost directly 40 plus, not 40, 40 plus questions came last year almost directly from the RIC course. This year we are expecting 50 plus. Maybe if I am lucky, you are lucky. There may be chance of 60 plus also. But one thing is true, our team is working like anything. Most expected questions will be there in the RIC course. So RIC course is the best one for the last 6 months. I request everyone, you can utilize. RIC course starting on 28th of August, Friday. This Friday it is going to start. Please utilize. So right, as of now, I think 70% discount going on. Use it. This will be the code EPT 610 EPT. Fine, that's okay. Let's move further. So why EPT? Right? If anyone having doubt why EPT, so premium courses are there. Affordable prices, premium courses there, affordable prices. Very, I can if you want, you can go and explore. Minimal costs are there. I strongly believe education is not for profit. I strongly believe education is for service. So premium lectures, live and recorded is there, affordable prices are there, and right. So in the RIC course, most of the questions, whatever we are teaching, expected questions, guaranteed questions. Last year 40 plus came. This year we are thinking 50 plus may come. Guaranteed questions are there. Next one, I am guiding from 2007. 2007 onwards, I am guiding the students. Exam oriented preparation, exam oriented, not more, not less. Exam oriented things only. In the EPT, we will teach only exam oriented stuff. Yeah, let's come to the next story. So formal languages, I think we done. So now how many formal languages are there? Let me write here. How many formal languages? Formal language, you said it's okay, sir. Ready, sir? You said formal languages. We are very happy. But how many formal languages? Remember everyone? Formal languages, how many? Everyone observe. So first formal language, see this one. How many are there? I'm going to give the answer. This is a very, very important. This slide is going to be very, very important. So first formal language is type 3 formal language. Type 3. Type 3 formal language, which is also called a regular language. Which is also called as a regular language. First one is type 3 formal language. That is the first one. Second one is type 2 formal language. Second one is type 2, which is also called as CFL, context free language. Context free language. Right? So next one is a type 1 formal language, which is called context sensitive language. Context sensitive language. Type, you can call type 1 also, context sensitive also you can call. Context sensitive also you can call. Right. Next one is type 0, which is also called as, which is also recursive enumerable language. Recursive enumerable. Recursive enumerable language. Recursive enumerable language. Some people are asking, sir, formal language, okay, ready, sir? Right? How many formal languages are there? You are saying many formal languages. How many? How many types are? Let me write now. How many types of formal languages? It is better to write types also. How many types of formal languages are there? How many types of formal languages are there? Right? That is the question many people are asking. So I'm going to explain now. How many types of formal languages are there? So totally four. Four types of formal languages. Four types of formal languages are there. Four types. What are those? Type 3, type 2, type 1, type 0. There are four types of formal languages are there. Type 3, type 2, type 1, type 0. Type 3, what is another name? Regular. You can say type 3, you can say regular. Right? Type 2, another name, context free language, which is also called CFL or CFL. Context free language or CSL. Context sensitive language or recursive enumerable language. Recursive enumerable language. Right? So how many types of formal languages? Four types. What are those? Type 3, type 2, type 1, type 0. What is the type 1? Another name, context sensitive language, CSL. Type 0, another name, recursive enumerable language, right? REL. Next one, among all of them, which one is superset? Type 0 is superset. Type 3 is subset. Right? Among all of them, which one is superset? Type 0 is superset. Type 3 is subset. So let me write this one. Type 3, right? Type 3, see everyone now? Type 3 is subset of. Type 3 is subset of type 2. Type 2 is subset of type 1. Type 1 is subset of type 0. This is the way. Alright, if you want, you can keep equal also. This is the relation which is going on. Right? This is the relation which subset are equal to means, yeah, actually it is a subset. If you don't want to keep equal also, no issue. Right? It is actually subset. Strict superset. Right? Remember, type 0 is strict superset. You can write like this also. Right? This is true means, right? Superset also true. Right? T3 is, right, strict subset of T2. That is also correct. If you want, you can write like this also. T3 subset of T2, subset of T1, subset of T0. Both are correct. Right? It is correct. Remember everyone, this is correct means this also correct. This is correct means this is also correct. Right? Be careful. Yeah, actually this is whatever I written on the right hand side, that is correct. This is correct means this is also correct. So this is the diagram. Who is a superset? T0. Who is a subset? T3. Right? And one more thing. So left hand side correct means right also correct. So be careful. Right? Fine. Until now everyone is fine. Right? So what is the T3? Another name? Regular. T0 another name? Recursive enumerable language. Who is the superset? Recursive enumerable language. Why more are there? Right? So T0 contain more. Okay, fine. That is also okay. Some people are asking, these many languages are there, sir. These many formal languages. Actually, formal languages are infinite, but the types are four. Four types are there. I'm repeating once again. Formal language, the number of formal languages available, so many. But if you divide, if you see all of them, only four groups. All formal languages can be divided into four groups. Sir, how many formal languages? Many. But how many groups are there? Four groups are there. What is the first group name? T3. What is the last group name? T0. Right? Fine. That is also okay. So what is the relation? T0 is superset. Right? So who is the subset? T3. T3 is a very small. T3 is subset of T2, subset of T1, subset of T0. Okay, fine. Four formal languages, everything is fine. Now some people are asking, sir, this is the language. Sir, T3 is a language, you are saying, okay, right? This language, which machine will accept? You know very well, Hindi language accepted by a machine, Indians. Hindi language accepted by machines or humans, right? Indians in the similar way, English language accepted by, right, humans, those are English people. French language accepted by French, right, humans, right, they are French people. Similar way, T3 language means regular language accepted by a machine, that is called finite automata. Regular languages are accepted by a machine, that is known as finite automata. Finite automata accepting regular language, like Indians are accepting Hindi language. Indians understand Hindi, right? In the similar way, context free language accepted by, right, push down automata, PDA. Push down automata, context free language is accepted by a machine, which is called push down automata. Right, next one, context to sensitive language accepted by linear bounded automata. A means automata. Next one, recursive enumerable language accepted by Turing machine. Some people are asking, sir, four types of formal languages, every language will be accepted by some machine. So regular language accepted by finite automata, context free language accepted by PDA, context sensitive language accepted by LBA, recursive enumerable language accepted by Turing machine. Right? So please be careful. Four formal languages, actually four types of formal languages. Every type is accepted by some machine. But if you observe clearly, right, context-free language internally contain regular, because regular is subset. When you say T3 is subset of T2, right? T2 contain T3 also. T2 contain T3 also. So please be careful. So if anyone asks you, just let me ask you one small, right? By default, careful everyone, by default every language is recursive enumerable language. By default every language is recursive enumerable language. Right? Understand, because recursive enumerable language is superset. By default, every language is recursive enumerable language. By default, every language accepted by Turing machine, because Turing machine is the bigger machine. By default, every formal language is recursive enumerable language. By default, every formal language accepted by Turing machine. Right? In the similar way, remember, right? Regular languages, every regular language is context sensitive language. Every regular language is context free language, because when you say it is a subset of all, right? So context, if you see the regular language will be accepted by finite automata. It is accepted by PDA also. It is accepted by LBA also, right? So it is accepted by Turing machine also. I will write clearly. I will write clearly. Please listen. I will write clearly. Please make sure everyone will listen. Regular language. See this. Easily will get. Among all of them, regular language is smaller. Regular language is actually regular language, which is also called as a T3. Actually, this language is accepted by finite automata. True. This language is accepted by finite automata. Finite among all the machines, finite automata is smaller machine. Among all the languages, among all the automatas, finite automata is a smaller one. So remember, regular language, which is also called T3, is accepted by finite automata. Smaller machine, remember, smaller machine accepting means bigger also will accept. So PDA also will accept. LBA also will accept. Turing machine also will accept. Next one. Context free language. Context free language, which is also called as T2. Right? This will be accepted by PDA. PDA acceptance means, right, above people. Right? So LBA also will accept. What is the LBA? PDA means we will see within a few minutes. PDA means push down automata. LBA linear bounded automata. Right? And Turing machine. Remember, context-free language cannot be accepted by finite automata because it is a smaller machine. Smaller machine cannot accept bigger languages. Context-free language is bigger, that will not be accepted by finite automata. So, context-free language is actually accepted by PDA. Bigger machines also can accept. Smaller cannot. Next one, context-sensitive language. Context-sensitive language, which is called T1. This is accepted by LBA. Right? LBA accepting means above machine, Turing machine also will accept. Remember, this cannot be accepted by finite automata. This cannot be accepted by PDA. Right? Bigger language will be accepted by bigger machines. Smaller machines cannot accept. But remember, smaller machine is accepting means bigger guarantee will accept. Right? See this one. So conclusion, if you observe clearly, finite automata accepting means these three people guarantee will accept. Right? Next one, reverse cannot be. Reverse cannot be. Right? So PDA accepting doesn't mean that finite automata will accept. Next one, LBA accepting doesn't mean that PDA will accept. Bigger means not smaller. Smaller means bigger. Smaller accepting. Definitely bigger will accept. Smaller accepting. Definitely bigger also will accept. But reverse not true. So see this one. See everyone. A Turing machine is accepting. I cannot say LBA will accept. Right? Next one. Can you see this also? Everyone see. Everyone observe. If some language is regular, understand. If some language is regular, someone said that this language is regular. If someone will say it's a regular, someone is saying it is a regular. Remember, it is a regular means it is a CFL also. It is a CSL also. Smaller means bigger. Some languages regular means it is a regular also, no problem. CFL also, CSL also, and one more. What is the answer? Recursive enumerable language also. But reverse not true. What is the meaning? CFL doesn't means regular. CSL doesn't means CFL. Next one. Recursive enumerable language. Right? Doesn't mean that. Some language is recursive enumerable. See, CFL, some language is CFL. I'm repeating once again. Carefully, everyone listen. If any language is regular, it is a CFL also, CSL also, REL also. If any language CFL, you cannot say regular. Every CFL need not be regular. Every CFL need not be regular. Every CSL need not be CFL. Every REL need not be CSL. Please try to understand. Smaller means bigger. Bigger doesn't mean the small. Same story. See, whatever I written here, this. Whatever I written here, smaller working means bigger will work. Same thing. One side I said in terms of machines. These are machines. These are languages. These are languages. Yeah, maybe if anyone having any doubts, sir, I have some doubt. Please check. Very simple. How many types of formal languages? 4. What are those? T3, T2, T1, T0. Which is bigger? T0. Which is smaller? T3. Next one, T3 another name regular. T2 another name context free language. T1 another name context sensitive language. T0 another name recursive enumerable language. Next one, T3 regular. Right? Who will accept? Which machine will accept? Finite automata. Next one, CFL, right? Another name is T2, right? Those languages are accepted by which machine? PDA. CSL, LBA. Next one, right? So recursive enumerable language, Turing machine. Among all the machine, bigger machine, Turing machine. Among all the machine, smaller machine, finite automata. Among all the languages, smaller language, regular. Bigger language, REL. Remember everyone? Remember everyone, regular is there everywhere because regular is subset of all. Remember, if something, right, some language is regular means it is CFL also. Because it is there in the CFL also. See, CFL means not only this total thing is CFL. CSL means not only this, total thing is CSL. So if any language is regular, it is a CFL also, CSL also, REL also. If any language is REL, I cannot say below people. REL doesn't mean that below people. Below people means above people. See this. Regular means finite automata can accept PDA, LBA, Turing machine. Smaller one will accept by every machine. Small machine also, bigger also. But see this one. So bigger language cannot be accepted by smaller machine finite automata. Right? Same thing I said. Do you have any doubt? Sir, I have some objection. Ready, sir, I have some doubt. In the flow, maybe I said something wrong. I don't know. In the flow, maybe I said something wrong. I really don't have any idea. I request everyone, do you have any doubt till now? Do you have any doubt till now? Please let me know. Is it okay? Can I move to next? What is formal languages? How many formal languages? Next one, for every formal language, which automata? This is just introduction. Introduction is going on. Within few minutes, everything is okay. Within few minutes, everything is okay. Can we go further? Can we go further? How many formal language? How many types of formal languages? 4. Right, perfect. If you are comfortable, let's move to next. Let's move to next. Everyone try to understand. See this? See everyone? Yeah, let me go to some other color. Yeah, same color, boring. Let me go to some other color. Yeah, this one I am going. Can you see this? This one I am going. Can you see everyone? Everyone see? Finite automata can accept only regular. Finite automata can accept only regular language because it is a smaller machine. Only regular it will accept. Next one, PDA will accept regular also, and PDA will accept regular also and CFL. So how many languages finite automata can accept? 1. How many languages PDA can accept? 2. 2 languages, number of languages I'm talking. Finite automata can accept 1 language, that is regular language. PDA can accept Regular also, CFL also. 2 languages it can accept. LBA can accept 3 languages. Regular also, CFL also, CSL also. 3 languages it can accept. 3. Next one. Turing machine can accept 4 languages. Regular, CFL, CSL, recursive enumerable languages. So 4 languages. Some people are asking, what are those 4? I written also, these are 4. So if you want, you can write in the type numbers also. I think it is type 3 it can accept, type 2 also, type 1 also, type 0 also. So it can accept 3 people. What are those? These. If you want, you can write types also. What is that one? I think it can accept. It can accept. What are those? T3, T2, T1. It can accept. It can accept 2 languages. What are those? T3, T2. Right? Remember, smaller machine cannot accept bigger. It cannot accept T1, T3, T2. So if you see this one, it can accept only one, that is T3. So finite automata can accept one language only. So how many languages it can accept? That is called expressive power. So finite automata expressive power. See, expressive power is E. How many languages it can accept? One language regular. Expressive power is 1. So finite automata expressive power is 1. PDA expressive power 2. LBA expressive power means how many languages it can accept? 3. Turing machine expressive power 4. Remember, E means expressive power. Expressive power means number of languages it can accept. So in terms of expressive power, if you see the relation, right? Relation in terms of expressive power, relation of all automatas in expressive power. In expressive power. So if you observe, so what is the relation? Expressive power of, right? Expressive power of finite automata, which is 1 less than expressive power of PDA, which is 2 less than expressive power of LBA, which is less than expressive power of Turing machine. Right? So 1 is less than 2, less than 3, less than 4. Right. Someone is saying Reddy sir. Thank you. Thank you. Do you have any doubt? I think all the things, whatever you knows, that only. All the things, whatever you knows, that only. Right? Please check. Whatever you knows, that only. If anyone is having small doubt, please keep in the comment section. The purpose of live class is, if you have doubt, you can ask. The purpose of live class is, if you have any doubt, you can ask. That is the purpose of live class. Live class basic purpose is that only. You have doubt, you can ask immediately. Right? Fine. I think these are very simple. Very simple here. Here, see. Because it is integer, na? One number less than, like that. Right? But here sets. So if you observe clearly, open. Let me go open. Here. Here, if you see, they are subsets. Superset is REL. Subset is regular. Right? So regular is subset of CFL. CFL is subset. These are subsets. See, sets. In the sets, right, there is a subset, something like that. Right? But here integers, remember. It's an integer. Expressive power of finite automata 1. Expressive power of PDA 2. Expressive power of LBA 3. Expressive power of Turing machine is 4. These are integer. So less than. Right? Less than. I hope you are okay. I hope you are okay. Let me know. Sir, I have some objection. If you don't have any objection, I can move to the next one. Let me move next. Let me move next. I am moving to the next one. So these are EPT last year toppers. I wish next year you will also be there in the toppers list. I wish next year I want to keep your photo here. Next one, if you are there in the class top 5, if you there in your class top 5, you will get the EPT subscription freely. Just I think a platform fee 2000 rupees you have to pay. Other than this, nothing there. But you should be there in the class top 5. If you there in the class top 5, you please send a mail info@exampreptool.com. info@exampreptool.com. You just send mail, we will give the EPT subscription freely. Right? The purpose is, I strongly believe education should be, quality education should be reachable to all deserving students. So if you are there in the class top 5, so please send to this mail ID. We are going to give EPT subscription freely. Now come to the next. I think everyone is fine. Now let me move to the next one. Everything is okay. Please observe now. Please observe now. Everyone listen. Everyone listen this. Everyone listen. Careful. Why these many automatas are machines? Machine and automata same. Why these many automatas? Why these many automatas? So one machine is enough, no? Why these many? Everyone know, right? Smaller problem, smaller machine. Bigger problem, bigger machine. Right? Every problem, I cannot take bigger machine for smaller problem. Solve smaller problem with smaller machine. Solve the bigger problem with the bigger machine. That is the best idea. For every right, bacha also. See, to kill the mosquito, mosquito is beating you. To kill the mosquito, there is no requirement of gun. So you know there is a one movie, Machar, right? I think some movie is there. In that villain will kill the Machar with the, he will try to kill Machar with the help of a gun, not required. What is the requirement of killing Machar with the help of a gun? Not required. Just simply throw something like this, it will die. So smaller things can be done with smaller machines. Bigger thing can be done with the bigger machines, right? Why these many automatas, right? We'll see now. That is the story. Can you observe here? This is a very, very important one. You may get some questions from this. You may get some questions from this area, right? Please observe. What is this? Can you see this one? L1 is equal to a power n, where n is greater than or equal to 1. So if you observe clearly here, minimum n is 1. 1a should accept, 2a should accept, 3a should accept, and so on, and so on. Right? So now listen, observe clearly. Minimal string is 1a. Whenever minimal string is 1 length, I'm just giving some suggestion. This language contains so many strings, but minimal string, if you see, minimal string is 1 length. So what you do is take 2 circles. If the minimal string is 1 length, take 2 circles. Take 2 circles. If the minimal string length is 1 length, then take 2 circles, means 2 states. Remember, every circle is a state. Take 2 states, means 2 circles you take. From the first circle to second circle, write one directed edge. There keep the whatever is the first string, keep there. So for the first circle, keep one initial arrow. For the last circle, keep one more circle, double circle. I am repeating once again. L1 is a power n, where n is greater than or equal to 1. Right? So L1 is a one language. What is the language? N number of A's, where n minimum value 1. So what you do is, if you see this language properly, the language is collection of strings. So if you see the string, first string is 1A, second string is 2A's, third string is 3A's, and so on, and so on. Right? If you see the first string, 1 length. 1 length means you take 2 states, 1 plus 1, 2 states. Right? With the 2 states means 2 circles you take. For the first circle, keep some name. For the second circle, keep some other name. Right? First circle, keep one initial arrow. Last circle, right? Whatever last circle is there, keep one more circle. That is a double circle. So two states are there. For the first circle, you kept initial arrow. That is called initial state. Right? For the last circle, you kept one more circle, double circle. That is called final state. Remember, it is initial state. Right? It is a final state. Final state. Initial state, final state. Okay, that's fine. Now, right, starting state to S1 to S2, by giving A, you are going to S2. Remember, every time automata will start from starting state. Every time automata will start from starting state. Start from S1, S1 on A, I will go to S2. So S1 is, right, remember, first string is completed. Where are you? You started from starting. But first string is completed single A, you are in the S2, which is final. Remember, at the end of the string, if you are in the final state, so string is accepted. So I will start from S1. S1 on A, I will give S2. So first string is only A is over. At that time, in which state you are? S2. So string is accepted. Let's go to second string, double A. Always start from start state. Start from start state. S1 on A, S2. S2 on A. Let's keep self loop. S2 on A, same state. So S1 on A, I will go to S2. Now I am at S2. S2 on A, again S2 only. Yes, S1 on A, I will go to S2. Now I am at S2. S2, one more A, I will go to S2. At the end, where are you? S1. From where you started? S1. Where are you finally? Final state S2. Means string is accepted. So double A is also accepted. Let's go to triple A. Everyone observe triple A. Initially S1. S1 on single A. S2. S2 on one more A. Right? S2 on one more A. S2 only. Next one. S2 on one more A. S2 only at the end of the day. Are you in final state? Yes. So after triple A also, you are in final. Means triple A also accepted. So what I mean to say is this particular automata will accept A power n. This automata is accepting language L1. This automata is known as finite automata. This is also called finite automata, which is also called as finite state machine. Finite state machine. Finite states are there only two states. Why these many automatas? So I took first language, right? To accept the first language, I created one automata. How? Take, right, one length. So minimal string, take one length. If the minimal string is one length, right, plus one you do. Two states start. Starts two states. So S1 on A, S2. At the end of the first string A, I am in final. But remember, always start from starting. Always start from starting. Please be careful. Right? Please be careful. So final conclusion. This language is accepted by finite automata. This language is accepted by finite automata. If you have little doubts, right, definitely in the further classes, it will be clear. Because it's the introduction. The introduction is going on. Why these many automatas? Why these many automatas are there? Someone is saying for any crash course is not there for DA and AI subjects. Yeah, if it is there, we will announce. If it is there, we will announce. Right? Thanks for asking. Thank you so much. Right? We will announce. Maybe next week we will announce. Why these many automatas? Right? So L1 is this. For L1, one automata we created. So remember, this automata name is called finite state machine or finite automata. Right? Fine. I feel you are really comfortable. Let's see one more. Everyone observe. L2 is equal to, careful, L2 is equal to A power n, B power n, where n is greater than or equal to 1. where m comma n greater than or equal to 1. Understand this also. You may not get clearly, but further you will get clearly. A power n, b power n, where m comma n greater than or equal to 1. A power n, b power n, where m comma n greater than or equal to 1. Right? Please try to understand. So this language, if you observe, minimal string AB. Next minimal A double B. Next minimal double A single B. Next minimal, right? A triple B. Right? Next one, triple A single B. So like that, many are there. So remember, minimal string is 2 length. 2 plus 1, 2, 3 states. Start the story with the 3 states. Start the story with the 3 states. Minimal string 2 length. 2 plus 1, 3 states, start the story. S1, any name you can keep. S2, S3. Last one keep a double circle. First one keep the initial arrow. Now from S1 to S2, single A. S2 to SB, single B. So remember, for AB purpose we are trying. S1 to S2 A. S2 to S3 B. So remember, I started from starting state. At the end of the string AB, I am at final state. So AB accepted. Now understand. Some people are asking, what about A double B, sir? A double B. Remember, single A you came here. One more B you came here. Afterwards, one more B. No problem. A double B. After A over, I am at S2. So otherwise, I will write also S1 on A, S2. S2 on B, S3. S3 on B, again S3. At the end of the ABB string, where are you? Are you in final? Yes. ABB also accepted. Next one. Can you see this one? S1. Be careful. S1, A. S2. S1, I think this also completed. Next one. S1 on A, S2. On S2, B will come, I will go to S3. If A comes, keep on the same state. You may not get, see what is happening. Just observe what is happening. So if you observe clearly, S1 on A, I will go to S2. S2 on A, S2 only. Next one, S2 on B, S3. Right? S3 on B, again S3. At the end of the, right? At the end of, right? Double A single B, you are at S3. So this also accepted. Next one, A followed by triple B. A, I came here. 1B, I came here. So many B's here. This also accepted. Right? Next one, triple A, single B. 1A here, 2 A's here, followed by B. I will be here. So if you want to can verify in this automata, everyone, you take any valid thing. From this language, you take any valid string. Any valid thing you take. Every valid string should accept. Every valid string should accept. You take any string, it will accept. Some people are asking, sir, 10 A's. It is a 10 A's followed by 5 B's. Will it accept? Check one time. 10 A's, where are you? After 10 A's, you are in the S2. Someone is saying something. You can send to me personally. Right? We will discuss. 888208990 right? So you can send to me personally. Thanks for asking. So in this automata, if you observe, after so many A's, S2, after so many B's, S3. So at the end of the string, where are you? S3. So you accepted. So remember. So this is also finite automata. Given language L2, accepted by finite automata. So remember, if any language is accepted by finite automata, let me write. Accepted by finite automata. If any language is accepted by finite automata, then that language is a regular language. Remember, given language is a regular language. This is regular language. If any language is accepted by finite automata, then that language is regular language. Given language is regular. Next one. This language also accepted by finite automata. Right? Finally, it is accepted by finite automata. Let me write. Accepted by finite automata. Then this language is regular language. Then this language is regular language. If any language accepted by finite automata, that is a regular language. So this is regular. This is regular. Right, fine. I hope people got till now. Right, now come to the next one. So you may not get, sir, how you are constructing automatas? Sir, how you are, next class is that only. Sure, right? Right, next batch mostly that only. Why these many automatas? So I think I tried L1 purpose, finite automata enough. L2 purpose, finite automata enough. Sir, I don't know how to construct finite automata. Further that only. Right? Sir, L2 purpose, how you construct the finite automata, you will get to know. This is just only introduction. Right? You may not get that one. Just know the terminology. That's it. Now let's come to L3. So L1 purpose, L2 purpose, I created finite automata. What is the finite automata? Collection of states. How you know starting state? Initial arrow. How you know final state? Double circle. Sir, is it edges or directed edges or undirected? Directed edges. So that you will get to know from where to where you are going. Sir, how can I say string is accepted? String over. Are you in final state or not? Sir, can I start from any state? No, always from starting state. Sir, string also, can I start string anywhere? No. Starting of the string, right? Every string starting, you have to start from starting state. How I know accepted string is over? In which state you are? And one more, what is the meaning of finite automata? Collection of states. How many states are there? 3 states. So for the L2, finite automata possible? Yes. So L2 is a regular language. Yes, because finite automata possible. Sir, finite automata construction to me very difficult, of course. For everyone difficult. Right? After maybe in the further classes you will be comfortable. Okay, fine, perfect. Let's go to L3. Everyone observe. Observe L3 once again. L3 is equal to one more language. L3 is equal to, see the answer? L3 is equal to A power M. Careful. L3 is equal to A power N. L3 is equal to A power N, B power N, A power N. Right? Okay, let's check. So I'm writing here. L3 is equal to A power N, B power N, where N is greater than or equal to. Remember your A's and B's, right? Equal. Your A's and B's equal. Understand? Your A's and B's are equal. Let's take the strings one by one. See the answer. Let's take the strings, right? Let's take the strings one by one. I think minimum N value 1, A, B. Next N value 2, double A, double B. Remember, A's and B's here should be equal. Previously A power N, B power N. But here A power N, B power N. A's and B's equal. Third string is triple A, triple B. Fourth string is 4 A's, 4 B's. Fifth string is 5 A's, 5 B's, and so on. Remember, your A's and B's should be equal. So minimal string is 2. Minimal string length is 2 length, 2 plus 1, 3 states. Start the story with 3 states. 3 states means 3 circles. 3 states means 3 circles. Keep the directed edge from left to right. So A, B. See, first we are trying for first string, AB. So S1 here, S2 here, S3 here. S1, S2, S3. So first string is successful. Remember, when can I say finite automata possible is if every string, if you can manage. I think first string I am able to manage. After AB, you will go to final. Okay, let's take the second. Double A, see this one, double A. I think only one A you done, double A. Let us assume I will keep A. After one A, I am at S2. After one more A, same S2, let us assume. Right? I am at S2. After S2B, I will go to S3. S3B, again S3 only. So remember, after double A, double B. String over, you are in the final state. Double A, double B also accepted. Double A, double B also accepted. Now see the next one. See the next one. Triple A, triple B. I think after triple A, you are at here. After triple B, you are at here. I think this also accepted. 4 A's, 4 B's. After A's, you are at here. After B's, you are at here. So this also accepted. Next one. After 5 A's here. After 5 B's, you are at here. It is also accepted. Look like everyone accepted. But the problem is everyone accepted. Remember, according to this language, A's and B's should be equal. First A's should come. So remember, A's and B's. A's equal to B's. A's and B's should be equal. First A's should come. First of all, these two equal. That is one condition. Second, first A's should come. Next B's. Remember, A's and B's should be equal. That is one condition. First A's only should come. Next B's. But the problem is everything is accepted. Okay, but if I give triple A 5 B's. If I give triple A 5 B's, so see what happened. After triple A, you are at S2. Right? Next one, after 5 B's, you are at S3. At the end of the string, it is accepted. At the end of the string, you are in S3, accepted. Remember, it is an invalid string. Invalid string also accepting. So let me write now. All valid accepting. All valid strings. Whenever something is correct, if anyone say this automata is correct, that means all valid strings should accept. Okay, accepted, no problem. All valid strings should accept it. Should accept. That is a one condition. One more condition is all invalid strings. Means if I give wrong string, all invalid strings should reject. Should reject. So if any, right, listen, if any automata for the given language satisfies this criteria, all valid strings should be accept. All invalid strings should reject. But problem is valid accept. Next one, valid accept, no issue. Valid accept, no issue. Valid accept, no issue. Valid accept, no issue. But see here, invalid still accepting. There is a issue here. It is the issue. All invalid should reject, but invalid also accepting. One invalid also accepting, it's fail. So, right? So let me write now, invalid. So double A is triple A 5 is invalid. Invalid string, but it is accepted. So the automata which you constructed, this is the automata what you constructed. This is the automata what you constructed. It is wrong. So for the given language, finite automata not possible. If you want, you can check. So for the given language, finite automata is not possible. Not possible means given language is non-regular. It's not regular. It is a non-regular language. Finite automata possible, regular language. Finite automata is not possible, non-regular language. If anyone says, sir, I will try some other way, try. For the given language, finite automata is not possible. Sir, can I try some other way? You try whatever way you want. For the given language, finite automata is not possible. The reason is, right, I am able to find out one invalid string which is accepting, means that, right, invalid string accepting means it's a wrong automata. Incorrect automata means automata is not correct because one invalid accepting. So finite automata not possible for L3. Some people are asking, if finite automata is not possible, sir, what should I do? You know very well, automatas are more. Finite automata is there, PDA is there, push down automata also there. Smaller machine is saying no, bigger machine you can try. So that is the reason these many machines. That is the reason these many machines. Can you see the topic name? Why these many automatas? Why these many machines? So small language, small automata, absolutely fine. Little more small, right? So once again, small language, small automata, okay, but a bigger language, right? Finite automata is not possible. How can you say bigger? Now see here. Here condition is there. Number of A's equal to number of B's. Comparison is there. Comparison. Whenever comparison, finite automata not possible. Comparison there. Finite automata not possible. Then you have to go to PDA. Finite automata not possible. Comparison. If you see comparison, then finite automata not possible. Then you have to go to PDA. You have to go to PDA. If anyone having doubt, let me know. So let me say this one. For the L3, finite automata is not possible. So given language is not regular language because finite automata are not possible. So some people are saying, how can you say not possible? One invalid string is accepting. AAA 5Ds is invalid, but it is accepting. So for the given language, finite automata are not possible. What is the meaning? Given language comparison required. In the finite automata, there is no comparisons. Comparison is there, finite automata fail. Directly you can say. Right? Perfect. Next one. If anyone don't know, please see this. If anyone don't know, please see this one. Right? So C language is freely available. Please utilize. Fully C language freely available. Utilize it. Python language also freely available in the website also, and right, EPT, right, YouTube channel also freely available. Discrete mathematics also freely available. Please use it. Discrete mathematics also freely available. Please use it. Right? And one more thing is, see this one. Assignments for every subject. 300 questions. Assignment we kept. It's a must-do assignment. It's a must-do assignments. Right? This assignment contain PYQs also there. Right? So next one, some PYQs also there. And right, best questions we kept for every subject 300. Toppers notes also available in the EPT website. Go and visit. PYQs also there freely you can utilize. Doubt solving also there freely. Please utilize. Next one, daily tests also there. Mark tests also there. I request everyone, please utilize. All the free resources. These are also free. Right? 3 courses, 3, right? 3 subjects are free. Please utilize. And one more thing is, these all are free. Right? Utilize all. Actual cost is for all these 7,000 rupees cost. We are giving 0 rupees. 0 rupees we are giving. We are giving freely. 7,000 rupees cost we are giving freely. Right? Yeah, perfect. So, and one more, if anyone want to join EPT courses, you can join the affordable. Very less price will be there. The only thing is live not available, RIC not available, test series not available. Because to make it affordable, so we deleted something from here. Live classes not there, only recorded, right? So, and one more thing is RIC not there, test series not there. Mentorship is there, recorded lectures are there, everything perfect. But very less price, please go and check. 6 months course is there, 12, right? 12 months course there, 24 months course also there. You can buy whatever you want. Premium courses, everything is available. Premium courses, little costly, but everything live is there, recorded is there, RIC is there, test series also there. Remember, from these two RIC test series, last year 40 plus questions came. From these two, last year 40 plus questions came. This year I'm expecting more will come. And almost free courses also available. Almost free. Almost free courses also available. Right, very less cost, very less cost. I want to make coaching as minimal cost as possible. Almost free courses also there. The only thing is, right, recorded lectures, old lectures we will give. Recorded old lectures we will give. Right, so no RIC also, no test series also. Right, almost free, very reasonable cost, very less cost. Old lectures we are giving. EPT old lectures we are giving. Right, so this is going to be 100 days. This is going to be 100 days. 100 days, right, almost free. Right, so you can utilize that also. We want to make as reasonable as possible. Gate plus placements, both combined you can prepare. This is also right. If anyone want to prepare gate and bit, gate and placement, this is better. Gate and PSUs, and only test series. You select whatever you want. Yeah, we made as reasonable as possible. EPT is now for every student. Every student can access whatever possible you can buy. Very minimal prices are available. Okay, now come to the next one. So remember everyone, L3. Careful, L3, A power n, B power n. Here comparison is there. What is the comparison? Number of A's. Number of A's is equal to number of P's. So comparison is there. Comparison means finite automata gone. Comparison. So finite automata is gone. Finite automata said I cannot. Then some people are asking, sir, what should I do? Go to the bigger machine. Try PDA. Try PDA. I'm trying PDA. Everyone observe. PDA means, remember, some people are asking, sir, what is a PDA? PDA means finite automata plus one stack. That is called PDA. PDA means finite automata plus one stack. PDA means finite automata plus one stack. Same finite automata, whatever you have, same, but the comparison purpose stack also there. Some people are asking, sir, how? So leave the finite automata part. So stack, using stack is comparing. See this one, using stack is comparing. Stack is for comparing. Stack is for comparing. Sir, how, sir? Can you see this one? L3 is going to be A power n, B power n means number of A's equal to number of B's. Let us assume 5 A's followed by 5 B's. Assume 5 A's, 5 B's. So everyone observe, initially you are at here. And finite automata, PDA contains stack also, take one stack. Stack initially contains stack Z0. What is the meaning? Stack empty. When you see the Z0 means stack don't have any symbol. Right? Please be careful. When you see stack contain top of the stack is Z0 means no symbol. And one more thing observe. One more thing observe here. Everyone observe. End of the string is assume hash. End, right? Stack is empty means Z0. End of the string means hash. See what is happening. So remember, PDA means stack is there. Initially stack contains Z0. End of the string is hash. How I know string over? Some symbol, hash. Some symbol will come. Now start from starting. See this one. See everyone. When you say stack, push pop. See the answer. What is the logic here is when A is coming, push. Careful. This is the logic. Right? So see the logic. You have stack. Using stack, how can you do this? A is coming, push. Again A coming, push. Again A coming, push. A means push. A means push. A means push. Okay, fine. Now listen. 2. See the answer. B is coming. B's are coming. Okay. Top of the stack is A's. Then pop. Remember, B is coming, top of the stack is A, pop. B coming, top of the stack is A, pop. Means for every B, cancel one A. B coming, top of the stack is A, pop. B coming, top of the stack is A, pop. B coming, top of the stack is A, pop. For every B, A cancel. For every B, A cancel. For every B, A cancel. Do you believe or not? Next symbol coming hash. What is the meaning? B is over. Hash indicate B is over. Do you believe or not? Top of the stack is Z naught. Means A is also over. This hash is saying that B is over. The Z naught is saying that A is over. Means for every B, A cancel. For every B, A cancel. So number of A is equal to number of B's. End of the string means hash. Top of the stack should be Z naught. So let's see. Finally, 3. Finally, Z, right? Hash able to see. Hash able to see Z naught. Hash and Z naught. Then means A is equal to B's. Finally, hash, right? Hash and Z naught is K. Means A is equal to B's. Means successful completion. Right? Means accepted. String is over, stack is empty. When I say string over means B is over, stack is empty, so accepted. So remember, with the help of stack, you are comparing. How you are comparing? A is coming push, B is coming pop. For every B, A pop. So this kind of story is not available in the finite automata. Finite automata having only states. With the help of states, now you can remember something. But with the help of stack, you can compare. So now my next question is going to be L3 comparison is there. So stack you taken. Comparison with stack possible. Comparison with stack possible. So L3 PDA possible means PDA possible meaning it is a CFL. L3 is CFL. Comparison with stack possible. So L3 PDA is there. For L3 purpose PDA is there. That means L3 is CFL, context free language. So now see the conclusion finally. L3 finite automata no, but PDA yes. PDA yes means it is a CFL. Finite automata no means regular no. Finite automata no means regular no. PDA yes means CFL. So L3 is CFL. So bigger, right? Bigger problem, bigger machine. Smaller problem, smaller machine. Let's go for one more. This will give more clarity. Can you see everyone? Here? L4 is equal to A power n, B power n, C power n, where n is greater than or equal to 1. Observe A power n, B power n, C power n, where n is greater than or equal to 1. Here remember A's, B's, C's, all 3 equal. So here also you have to compare. See this one, A, B, C. Okay. Next one, double A, double B, double C. Yes. Triple A. Careful. Triple A, triple B, triple C. So and so on. A is equal to B is equal to C. So PDA, PDA contain one stack, right? Take one stack. PDA contain one stack. Take one stack. So let me try. This one possible or not with one stack. Let me try. On Z0, A is coming push. Okay. On Z0, I'm trying this. On Z0, A is coming push. Okay. See the next one. Whenever B is coming, interesting, see this one. Whenever B is coming, for every B, pop A. For every B, pop A. For every B, pop A. Do you believe or not? Whenever B is over, A is over. So A's and B's equal, okay. But with whom you will compare C's? With whom you will compare C's? Suppose if you don't compare, C's may be more, C's may be less. So remember, here two comparisons are there. Let me check. Here A's, B's you have to compare. That is one thing. And B's, C's also you have to compare. That is one more thing. Here two comparisons are there. First comparison, second comparison. So with the help of one stack, you can do one comparison only. If you observe clearly here, A is equal to B's. But how will you compare B's and C's? Because B's no more exist. Only C's are there. So with one stack, you can do one comparison only. So I don't know how to compare B's and C's. For every B, cancel A. For every B, cancel A. B is over, A is also over. Means number of A's equal to number of B's. Perfect. But C's also have to compare with the B's. But B's no more. B's not exist. B's no more. So remember, more than 2 comparisons. See this one. 2 comparisons needed. 2 comparisons needed. But right, PDA can handle one comparison only, because one stack. PDA can handle one comparison because of one stack. So for the given language L4, PDA not possible. So you have to go for bigger machine. Bigger machine is Turing machine. So LBA is only theoretically there, practically not there. Right? So directly let's go to Turing machine, because Turing machine can handle any number of comparisons. 1 comparison, 2 comparison, 3 comparison, anything he can handle. Right? Let's see what is the Turing machine. Turing machine is nothing but PDA plus one more stack. PDA already contain one stack, right? So it's going to be finite automata plus one stack already there, plus one more stack. So which will goes to finite automata plus 2 stacks. Remember, 2 stacks are there. Turing machine is nothing but 2 stacks. Let's take 2 stacks. Some people are asking, sir, L4, let's see, 4 A's, 4 B's, 4 C's, how it can handle, sir? String is over by hash. Initially stack is empty, Z0. Now see what happened. Remember, you have to do 2 comparisons. A's will come push. So I'm writing first step, A's push. Okay. Now see the second step. B's, then see this one, B's pop from S1 stack A's. This is S1 stack. Pop, right? Pop from S1 stack A's for every B. And one more thing, push into S2 stack B's. So what is the meaning? Careful understand. So whenever B is coming, for every B, pop A, push B. For every B, pop A from S1. For every B, pop A from S1, push B into S2. 2 operations you should do. Right? For every B, pop A, push B here. For every B, pop A, push B here. For every B, pop A, push B here. So now first stack is empty. See, B is over. First stack is empty, means A is equal to B is already done. Now, sir, C's you will be compared with B's, na? Already B is there. For every C, see the third step. 3. Right? Whenever C is coming, pop from S to B. So for every C, pop B. 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 Whenever hash K means C is over. In the second stack, you are able to see hash, right? So I think Z0. That means B is equal to C's. So one is A is equal to B's, another one is B is equal to C's. So A is equal to B is equal to C. 2 comparison. A equal to B and B is equal to C. So remember, with 2 stack, you can do any number of comparison. Some people are asking, sir, will it work for 3 comparison? Yes. 10 also. If you want, you can check. Some people are asking, sir, one more comparison required. How, sir? Do you believe or not? One more comparison is required. That time this stack is empty. Every time one stack is empty. While doing this is empty. Right? While doing this is empty. Check. So every time one stack is empty. So that is the reason people used to say, with the Turing machine, you can do any comparison. So see this one. one comparison, can you see finally? One comparison, so I will write somewhere. Right, let me complete this also, I will conclude. So if you, these are the people who taken the EPT placement course, they got big companies. So if you are preparing for a placement, you can take DSA course, you can take DSA course, DSA plus system design course, DSA practice course, interview course, languages, and right, full stack web development, app development course, front end course. So anyhow, these two are free. And one more thing I want to say, 70% off. You can utilize. This is the code you can use. Now come here. Final conclusion. See the final conclusion. Conclusion. Everyone understand. No comparison. Finite automata pass. Next one. One comparison. Finite automata comparison means finite automata fail. Right? So PDA pass. Next one. Two comparisons. Two or more. Finite automata go. PDA go. Turing machine pass. So be careful. So this is some rough idea, but don't do anything blindly. Right? So if at all no comparison, almost right, finite automata will work, but you have to check properly. There may be indirectly, directly some comparisons. So I'm really saying to you, right, this is some idea, I'm giving some idea. As of now, I can say this only. Further classes, I will say so clearly, so deeply. Further classes, I will say so clearly, so deeply. As of now, I can say only this conclusion. So by seeing that no comparison, maybe finite automata will work. One comparison, by seeing comparison, finite automata fail. Right? So next one. So one more thing, PDA pass means Turing machine also will pass. See, smaller machine working, bigger also will work. Smaller machine is working, bigger also will work. Be careful. Smaller working means bigger also will work. One comparison, finite automata fail, PDA pass, Turing machine pass. As of now, I can say only this conclusion. I cannot say more than this. More deeply, little more deeper, we'll see afterwards. As of now, this is what is the problem here? Why these many automatas? That is the question what we are asking. Why these many automatas? Right? So see, this is the place where it is started. Why these many smaller problems? Smaller languages, smaller machine. What is the meaning? No comparison. Finite automata may work. You have to check carefully. But further we will see so deeply. As of now, I can say this. Next one. Comparison concept came. Finite automata gone. More than one comparison, PDA is gone. Right? Fine. Today we done the very decent work. Tomorrow we'll see further story. Thank you. And those people who are watching this one, if you really got everything, please comment in the comment section. Sir, I got everything. Tomorrow we'll see the right remaining story. Tomorrow total class, finite automata construction. Here, what is the language? How many automatas? How many languages? What is the relation? So today some discussion about that. Tomorrow, finite automata construction. We'll see some problems on that. NFA, TFA. Tomorrow, at the end of the tomorrow's class, you will see NFA, TFA, regular expression, all the things you will see tomorrow. Right? Thanks everyone. See you in the next class. Tomorrow, 7:30, we can have. Tomorrow is a very important class, NFA, DFA, right? Regular expression, right? We'll do approximately 10 to 20 problems we'll do. All models will cover. If anyone having little doubt also, you can ask me. Chalo, thanks. Thanks everyone. Good night.